I am thrilled to welcome all of you to the 2025 Taskar Memorial event. This is our 11th year celebrating Ben's life in this way. And every year I tell myself that I'll say something a little bit more personal in this event, and it's always harder. So I will not, but I will leave it up to our speaker to take on that charge. We've welcomed here to UW speakers of all kinds who have interacted with Ben throughout his career, his professional path. And I think this is the first time that we actually have someone who's been more of a family member present this and his work. So I thank you for joining us today. Yosef Grodzinsky is currently the head of the neurolinguistics lab at Edmund. I'm sorry. Thank you for asking. Am I not audible? It's difficult. I see.
Oh, no, now that's working now.
Okay. All right, I'll start over. Not all the way over. Yosef Grodzinsky is currently the head of the neurolinguistics lab at Edmund and Lily Safra Center for Brain Research at the Hebrew University of Jerusalem, Israel, where he's emeritus professor. He's also a researcher at the Institute for Neuroscience and Medicine, Forschungszentrum, Jülich, Germany, trained in formal linguistics, neuropsychology, and cognitive neuroscience. He was trained at Hebrew University, Brandeis University, and MIT. Prior to his Jerusalem and Jülich positions, he was faculty member at Boston University School of Medicine, Tel Aviv, and McGill. Theoretically, he has been long working on formal syntax and semantics. Experimentally, he has been looking for brain mechanisms that support linguistic knowledge. He has done so through studies of people with aphasia, subsequent to focal and diffuse brain disease, which causes selective language disruption. He has also been engaged in neuroimaging experiments with healthy individuals whose brains are scanned as they perform various complex language tasks. He has lectured widely and was visiting professor at Princeton, École Normale Supérieure, MIT, Jean Tong University, among others. He has won several prizes, awards, among them are Humboldt Prize, Senior Canada Research Chair, Sloan, Allon, and Rothschild Fellowships. His current experimental work has sent him back to the clinic, working in operating rooms. He and his neurosurgical colleagues in Germany have been developing new linguistic tools for intraoperative assessments of language abilities during awake neurosurgical procedures, during which brain tumors, mostly gliomas, are resected. As a sideline, he studied history and published multiple articles and books on modern Jewish history. Today, he will give us a neurolinguistic perspective on large language models. The talk is titled My Breakfast with Ben, Chomsky, the Brain, and the AI Fantasy. And I thank you for being here.
Thank you.
Please welcome.
Thank you. Yesterday, in preparation for this event, which excites me, I watched Drago's lecture from last year, and it was a fantastic lecture, and mine's going to be quite different. Certainly won't measure up. But first, I would like to say some things, and I'm going to read them, because otherwise it's going to get embarrassing. I'm very honored to be here and deliver the annual Ben Taskar Memorial Award lecture. I'm especially honored to do so in the presence of Ben's parents, Celia and Marek, who are here with us. Aviv, of course, Aviv Taskar. And Anat's mother, Nurit, who's on Zoom and happens to be my sister. Yeah, I'm here in the family capacity. My dearest niece, Anat, in the picture here with Ben and Aviv and my daughter, Amalia, has been very close to me since she was born. And when we were lucky to welcome Ben into our family, I did my best to become close to him as well. So I loved him to pieces, and fortunately, he reciprocated in kind. We played, we had fun together in New York, Montreal, LA, Philly, and Tel Aviv. We even traveled to Greece together, the three of us. It was always wonderful, warm, and full of love. But more to the point, we argued a lot, mostly about language. The only topic I could feel I knew a bit more about than he did. I especially cherished the arguments we had over the many kinds of shakshuka that Ben loved to make for breakfast, and at which he was extremely good and creative, like everything else he did. So Ben was fun to argue with. He was smart and charming, he was knowledgeable, and he was strategic, never showing a card to the opponent, me, unless absolutely necessary. And he was also kind and gentle, with minds that were slower than his, mine. No wonder that, like those in the audience who knew this unique guy, I miss him terribly. So, and yeah, he loves to win. He loved to win. And as we shall soon see, he did so without ever passing up an opportunity to make fun of Uncle Joe, that's me, which he did graciously and with compassion. So to an extent, this talk can be viewed as an extended meditation on the multiple debates I was lucky to have had with Ben. I hope he's looking at us now from above, laughing and saying, "So, Nu, what's your point, man?" Okay, let's wipe our noses and start. Okay, so when we come to here's some questions that seem to be important. And again, I apologize for this being overly gushy, but that's life. Here are some questions that seem to be important. First of all, what do we know when we know language? That's a question regarding a theory of knowledge to the extent that it exists. Secondly, how did we come to know it? That's a question of development, acquisition, unfolding, whatever you will end up calling it. Thirdly, what does our brain do when we use language? And that's something having to do with brain theory of some type. And finally, there's an engineering project, which many of you are engaged in, which is how to build an efficient language program. And this is something that has gained huge amounts of attention, quite obviously, over the past few years. It's pretty clear that these questions really bear on the nature of our humanity, the nature of scientific explanation, and also on good engineering, okay? And I just want to be clear, at least the way I view it, which some might find simplistic, science is about understanding the world and exploring its structure and nature, whereas engineering is about building useful tools. I don't know which is more difficult. I think engineering is more difficult just because I can't put two pieces of anything together. So here's what's coming. First of all, I'll mention in passing a perennial puzzle concerning knowledge and learning, which many of you are familiar with, I guess. I'll talk about two current extreme positions about language. I'll then compare some aspects of linguistic theory to large language models and point to some problems and maybe prospects. I'll mention a couple of engineering aspects of this debate, something that engineers might use as a take-home message. And then I'll look a little bit at neurolinguistics, brain, and the final punchline would be that whatever evidence there is, it suggests the need for small linguistic neural systems that make up our overall linguistic ability, and that might seem to be a lesson to be followed by language modelers. Mostly these are excerpts from a forthcoming book of mine that's called How Deeply Human is Language, with a subtitle like the title of this talk, with the exception of the Ben breakfast. And going a little bit back by just like a little bit over 2,000 years ago, there's a perennial debate, which is, I think, almost mentioned almost for the first time in the Men of Plato's famous dialogue. And there's an eternal debate on learning. The question is, in his case, can virtue be taught at all? Or in our language, what is knowledge and does it even exist in our minds? And in this dialogue, what Socrates does when he has a dialogue with this character Meno is show that in fact knowledge is nothing but recollection, but just like remembering, if you want. It's nothing but recollection. And he shows that, at least he claims to show that by having a debate on, by having a question answer session with a slave boy who he shows and claims to show at least that the slave boy, who's a symbol of zero knowledge, can actually prove the Pythagorean theorem. That's it's a fantastic dialogue, and I highly recommend it to those of you who haven't seen it. But it's basically what's called the nature versus nurture debate. It's been known for many years as such. And the question is, can science decide this debate, or should we just leave it for philosophers? And there are two positions that are currently kind of salient. One position is the linguist's position, best um, manifested through Chomsky and Chomsky's linguistic theory, his symbolic grammatical rules, symbolic systems applied both in syntax and semantics. Drago told me on his way to his seat, he said, we tried to code these and failed and gave up. Not failed, but gave up. That's what you said, and I think it expresses well the sentiment of very many people in NLP these days. And the one conclusion, apart from the need for symbolic systems to account for linguistic regularity, one conclusion is that some of the linguistic knowledge must be innate. That is, it's not something that is acquired on input. And the other position, which has gained a lot of traction over the past 30 years or so, is best symbolized by those like deep and recurrent neural networks, which actually assume no symbols, or at least claim to assume no symbols, and actually claim that the only way for us to acquire our skills is by experience and by having statistical generalizations over input exclusively over experience. There's nothing innate. So you might see that, without even looking at any details, there's quite a conflict between these two approaches. And I want to show you how it manifests verbally by like some kind of punches that are exchanged. So Chomsky, I think in the last published work last publication that he had before he went silent. Before he went silent, he's still alive though. Um, he wrote in an article in the New York Times with two co-authors, the human mind is not like ChatGPT and its ilk, a lumbering statistical engine for pattern matching, gorging on hundreds of terabytes of data and extrapolating the most likely conversational response from a probable answer to a scientific question. That's kind of decisive, maybe a little bit overly decisive. And next to him, you have somebody like Jeff Hinton, who 2 hours after he was told that he won the Nobel Prize in Physics, he was interviewed by on the Nobel website. They have this thing called First Impressions Interview, which is very sweet. And one of the most urgent things for him to say as he concluded his 5-minute interview is neural nets are much better at processing language than anything ever produced by the Chomsky School of Linguistics. Quite amazing, actually. This is what he really had to say. So again, these are two extreme positions. I personally think that both are not useful. Chomsky was my teacher, he was my mentor, but it doesn't mean that what he says here is particularly useful. And I can tell you that in my shakshuka breakfast with Ben, I had discussions with him all the time about such things. We started it, I think, around 2005, something like that. And at the time, there was this thing called Penn Tree Bank. Some of you may remember that. And everything was about part of speech tagging and things of that type. And I kept asking him questions. Why progress for you is moving from 91% success to 91.3% success? Why is that considered an accomplishment? Why do you have 39 arbitrary parts of speech that you assume, sometimes 46? Where did you get these things? I don't understand. And he had a very clear answer. He always said the same thing. He said, and I've been quoting it forever. He said, you really don't get it, do you? He said, I'm an engineer. It's not about understanding. It's just about beating the other guy. You have no idea how many times I've quoted this. And well, it's the same position basically as Hinton's, except a little bit more humble and somewhat tongue-in-cheek. And one thing I hope to show is that both are wrong, namely both Hinton's approach and Ben's approach. So, you know, okay. So how can we tell which approach is right between these two? There are several kinds of things that one might look at, and I'm just going to go briefly over these. And perhaps the most important thing that linguists try to do theoretically is to set up constraints on what a possible grammatical system can be. It turned out to have a lot of cash value in terms of like explanation, and this is what people do. And the question is, are there constraints? And what I will try to argue, and I have been arguing, that linguistic theory has many of these, whereas large language models, as applied to language, have very little. I should say that all my comments here are restricted, all my critical comments are restricted to language. You know, and not only are they restricted to language, but to this aspect of language. So there's Emily Bender here, who has been very prominent in making linguistic criticism of a slightly different kind, I think, than this. And this complements them. It doesn't go against anything. It complements them. And hopefully it has some value in itself. But the point is, the critique here has only to do with language. In vision and in audition and even in speech, the value of large language models has been fantastic. And you know, what do I know from speech and things of that kind? But when I look at what's happening in vision, and I will in just a few minutes, I'm in awe of what's happening there. It's just in the ways large language models are applied in devices like ChatGPT that my comments are pertain to. So, you know, the first thing is the existence or non-existence of constraints of the type that linguists like to talk about, which linguistic theory has, and presumably large language models don't really have much. A second question is, how do you construct your benchmarks? This is a critical question. What are the things on which you test your machine? So one thing that Jeff Hinton and many around in the large language model community, they've been applying something that they call the Turing test. So you talk to the machine and it shoots back at you and you can't distinguish between it and a human. I don't understand what this test means. It's not a test. It's not, it doesn't have a formal characterization. It doesn't have properties that I can point to other than this kind of thing that, you know, if you ask me or you, can we distinguish between the speaker and a computer? We cannot. But we will see a little bit more about that later. And the point about setting benchmarks in a linguistic way is that they have to be theory driven. That's the requirement. And I think I'll try to convince you that there are at least some cases, I think there are many, but I'll give you a couple of examples where a theory-driven construction of examples actually leads to discovery. I'm a very concrete guy and I move on empirical arguments. So hopefully I'll show you something in this respect. And lastly, when we talk about architecture of the system, well, maybe the brain can come to our rescue and help a little bit. And when we look at language in the brain, this is something that I spent a little bit more than 40 years trying to understand. The picture that emerges is not quite uh, um, something that large language models, constructors or their students in the brain take into account, but we'll get there. So here's the plan. The plan is to look at these things, and several things I can concede right away. Linguistic theory is not runnable, so runnability has been a test. It's kind of a criterion for the goodness of a system. Again, engineers, that's what they need. And it's quite clear, as Drago said, that linguistic theory has not been particularly successful. It's not clear how you implement symbolic rules in computer systems successfully and solve the problems that they raise. Whereas, large language models obviously succeed quite compellingly. I will then argue, and I'll show you with a couple of examples, that large language models, when applied to language in a particular way, actually fail. They're too weak. And they fail on tests where we humans succeed quite well, and the theory succeeds in predicting. In fact, this theory is the body of statements that led us to the discovery of these facts. And I'll show you this in three ways. One is we will look at something called constraints on pronominal reference, specifically if there are linguists in the crowd. Emily's here, I can see. So parallelism in VP ellipsis. This is like a kind of fancy constraint, but it's quite instructive. We're then going to look at issues having to do with syntactic ambiguity. And finally, we will actually force large language model proponents to put their money where their mouth is, which is we will look at next word prediction, which is something that a big deal is made of in some somewhat complex cases. And finally, with respect to resolution, I'll show you that the criteria for neurological resolution set up in the world of vision are very high, the bar is extremely high. And then we'll see how it gets lowered when one talks about language in the brain. So let's go, okay? So let's look at this sentence. And in a minute, you'll see, I think it's worth the effort. Let me walk you through this. I assume no previous knowledge, and I think it's kind of worth sweating over such an example for 5 minutes. It gets you somewhere. So the first question is, John walked his dog, and so did Mary and Bill. What does it mean? Okay, so is this sentence ambiguous? So here's one meaning. It has one meaning that here you have this, here you have a scenario. So there's like John walking John's dog, Mary walking Mary's dog, and Bill walking Bill's dog. So each of them has his or her own dog, and they walk these dogs. So this interpretation, as you can see here by the arrows, means John walked his dog, Mary walked her dog, and Bill walked his dog. And what's special about such constructions is that there's a piece missing after the and. So this is an ellipsis sentence. There's a piece that's missing. So everything about walking his or her dog is not here. And it somehow gets reconstructed in our head, somewhere in our head. So there's something missing about this sentence. And the question is, what exactly is missing and how to interpret it? And as you can all see, I hope you all agree that this is a valid interpretation of this sentence, namely that there are three dogs. It's possible, at least it's consistent with the meaning that there are three dogs, and each of these people walked his or her own dog. All kinds of things to be said, but that's essentially where we're going to stop. Okay, but there's another meaning here. And the other meaning is what you see here. Okay, this is Mary, John, and Bill, and there's just one dog, and it's got to be John's dog. No one else. So this meaning is that they collectively walked John's dog. Okay? And I think it's easy to convince people that these are the interpretations of this sentence. And if that's the case, we might want to see whether. Is it okay?
I was going to see if I could get the light.
Perfect. Thanks a lot. Thanks a lot. And if that's the case, let's see what ChatGPT says. And amazingly, ChatGPT identifies these two meanings rather quickly. You can read through it if you want, but basically it acknowledges that these are the two meanings. Fantastic. This is great. And everybody's happy. But wait a minute, just hold your horses before you rejoice. So here's a third possible meaning. I'm sorry, yeah, the same thing. Sorry, these are the two meanings. But here's a third possible meaning. You see, there are three individuals And we don't know, we have no information about the number of dogs. And we also do not know which is assigned to which. So here's another possibility. There are two dogs. One is let's say one is Mary's dog, and it's walked by Bill and Mary, and John walks John's dog. Nobody said anything against that. But it turns out that humans, whoops, what happened here? It turns out that humans say, no, I hope you're human. And then you say no, and this is not a possible interpretation of this sentence. Namely, this sentence cannot mean, namely, John walked his dog and so did Mary and Bill. It cannot mean that Bill walked Mary's dog and Mary also walked Mary's dog. It just cannot mean. This is just a factor of English. It follows from some constraint, some syntactic constraint called parallelism, complicated story, but it doesn't matter to us. This is what led to the choice of this test in the first place. But the important thing is that we rule out this kind of interpretation. And it will come as no surprise if I tell you that, in fact, ChatGPT very politely apologizes and accepts this interpretation. You can try. See, one risk that you always run when you find these kinds of examples is that, of course, everybody runs immediately to ChatGPT and plays with it. No, this is part of the game here. Actually, in this book, I tell the readers how to test it and how to play with it in many different ways. I encourage everybody, because everybody does it anyway. Why not? It's a fantastic game. And what's interesting about the examples that I give here is they're extremely stable. I've been testing them for like a couple of years. They don't change. Nothing changes. They're quite stable. And if you do it and you get another response, is because you didn't control for certain variables. I can already tell you. I had these debates with several people, and it's easy to show that some people say, well, maybe Mary and Bill own the same dog, unbeknownst to somebody. No, okay, there are ways to control for that. Anyway, so this is one case in which large language, ChatGPT at least fails where we succeed. And there's something important about it. So the first question to ask, and I can see it, I think, at least in some eyes, is why should we care about such examples? It's really some kind of an arcane example completely cooked up by some crazy linguist. Why should we care about such things? And what I'm going to try to answer to convince you is that we should care exactly about these cases and not about other cases, namely the cases that are standardly used as tests of GPT are just the wrong tests. They don't probe the right thing. So it makes them usable. But if you really want to understand what you're doing and get it right, these are the examples that you have to go for. And we'll get there in just a second, okay? So let me go quickly over a similar example. And the similar example has exactly the same syntactic and semantic properties. I just replaced the words. So John rode his horse, and so did Bill and Mary. And once again, that there's two possibilities here that you can think about: John, Mary, and Bill riding horses. But look what happens here. All of a sudden, ChatGPT accepts and, in fact, volunteers the unacceptable interpretation in which Mary and Bill are riding the same horse and John is riding a different horse. And moreover, what it does, it actually rules out. It rules out where is the ruled out interpretation? It rules out the third possibility, namely the possibility in which all three of them are riding John's horse, which is the analog. It took me a while to find it, to cook up this picture, but never mind. But you get the idea. You get the idea. It took it a while to rule out this kind of example. And it did, wrongly, because we accept the possibility. This is, to us, a valid interpretation of the sentence, John rode his horse, and so did Bill and Mary. And ChatGPT says, no, this is unacceptable. So what you get here is not something that is mistaken. You get inconsistency across cases. The situation is getting worse by the minute. Okay, so the inconsistency manifests itself again by the fact that what we accept, what we accept, this machine rejects. What we reject, this machine accepts. And you get inconsistency across trials. This is the previous case, namely with the dog, walking the dogs, and this is the case in which we're talking about riding the horse. So this is a problem. And again, once you can ask again, why should we care about this? It's not used this kind of sentence is not used very often. I think there's a name in computer science, it's called being out of distribution or something like this. And I learn every time I meet a computer scientist. Luckily, I speak to Anat a lot, so I learn something new every week, or something like this. But I mean, make no mistake about it, I'm part of a brain research computational neuroscience center. I'm the only one in the building who's not doing machine learning, really. So I encounter types like you guys quite often. Uh, uh, and and so the question is, why should we care at all? And I think we should care a lot because, first of all, if you want to build a good machine, you don't want it to make mistakes. So you should find the right benchmark, because eventually, even if you have very few cases of this type, they would end up showing up sometime. And you want to make sure that they don't stand in your way. So this is just an engineering thing of getting your machine to do things right. But scientifically, when you think about it, if these things are rare, they create an even worse problem. Because if they're rare, then how come you learned them? What's the input on which you learned them to begin with? So these are exactly these cases that seem to be crazy because you don't hear them every day, are exactly the cases where you should put your effort on. So this is like lesson number one. And as you can see here, I looked up, again, it's difficult for me to know how somebody came up with the statement that 1% of the sentences have ellipsis. I don't know, but let's say it's even true. So if it's true, it's kind of rare, I would think. Then how come we know them so well? How come nobody rose? I think, I don't encourage politeness in terms of arguing with me. And still nobody got up and said, no, you're wrong. This is not the right interpretation in English. The ambiguity that you saw is not the right one. And the example that was ruled out was not correctly ruled out. Here's Drago. Okay, let's hear it from Drago.
How much of this comes from common sense, right? So it's not about the structure, common sense, right? For example, well, we've never seen three people walk a dog, but three small people can ride a large horse, especially if it's in fantasy novels, right?
Sure.
And that is common sense, and it's not tied to the sentence parsing. It's a different kind of dependence. And humans maybe.
Well, first of all, the answer is zero comes from common sense. I can tell you that, zero, okay? To make it simple, okay? But to make it, just think about it, forget about the horse riding. Just think about the walking the dog. Why did it get it wrong? And I deliberately chose a crazy example in the second case. It's not accidental. I deliberately chose it to show you that the behavior is simply inconsistent. Okay, so there's nothing, and I didn't invent this. This kind of ambiguity in VP ellipsis and constraints thereof has been known since, to my knowledge, since 1968. So there's a famous paper by Ed Keenan and somebody, I forget who else, I think Emmon Bach, Emmon Bach and Ed Keenan. From 1968, they discovered this kind of phenomenon. It's called the strict and sloppy identity pronouns. It's been known for a long time. Thousands of linguistic minds have been breaking their head over this. And there are all kinds of solutions, with certain degree of success. It's really not a question of common sense. I mean, it's a valid kind of observation, but it's really not a question of common sense. It's a little bit like something that you've heard in your youth. I mean, you're still young, but still in your youth, which is the first class in an NLP, the first lecture in an NLP class. you hear, they tell you, there was this guy Chomsky, and he had this sentence called "colorless green ideas sleep furiously." Maybe you remember this. You don't, okay? Because I think you were at Stanford, right? So they teach this kind of stuff at Stanford. Okay, well, Emily, do they teach this kind of stuff? Do they teach? Yeah, they do. Okay, so the point here, the point that this is something from around 1955, and the point Chomsky had there is that you can have well-formed sentences that are totally nonsensical, and this point carries over to such cases. There are instances in which the interface with semantic considerations becomes important, but this is not one. So, so the answer is a flat, in this case, the answer is a flat no, but keep asking. Okay, so, again, my goal here is really to convince you that these kinds of cases are pertinent. They're not just some arcane stuff sitting in the back of something. And this is exactly what we should understand. Okay, and you can see there are opposing predictions here. And just as a small experimental point, kids have VP ellipsis, which is the name of this construction, at age 3. So it's not as if they have these kinds of ambiguities, but they do have ellipsis very early on. We did it with Isabel Deschamps and several other people at McGill. We did a very simple thing. There are these huge texts, something called childless database, and all we did was look for all the sentences in certain kids' um, um, speech that contained the word "to." It was a very cheap thing to do, and then you just rule out the "to" as an intensifier, and you end up counting, and you see that at age 3, tons and tons of kids have ellipsis. Quite amazing when you think about it. Because this is a missing piece that must be reconstructed. And from this dialogue, you can see that the child, no doubt, reconstructed the missing part correctly. You can see that. And, I did some kind of rough calculation for how many sentences you have been exposed to at age 3, and it's about 2.5 million or something like that. Not much. If you're listening all the time, that is. Okay, example number 2, and then this is going to be the last example. This is like a classical ambiguity. I know of people who pointed it out in the 1930s, but I would imagine that if you go to some Greek scholarship in the pre-BCE or something like this, you will find such ambiguities as well. People there had brains and they could think about such things. And this ambiguity is one that concerns what first scopes over. Is it the first school or is it the first school principal? Very basic. And the thing is, the reason to look for such things is pretty obvious. In systems that are based on ranking, it's very difficult to create situations where you would identify an ambiguity unless it's listed for you as some kind of encyclopedic knowledge. And it turns out that indeed, this machine is pushing towards a particular kind of interpretation, which is the one, it's the first ever principle, it's the first principle mentioned, whatever. And then you ask it, could it mean? And he said, yeah, this is another interpretation, the principle of the first school. Wonderful. So if you push it, it doesn't object. But then the question you might want to ask is, does it generalize? Did it get it? Is it learning anything? Now, granted, this is a very superficial way of measuring learning, but still, you would expect this kind of machine to be quick on these very, very simple and basic examples. And it's not, it fails. It really does. It's just completely unable to do this. So here's, yeah. So here's the standard kind of objection that I get when I show this to people. It's what we call, my friend and colleague Danny Fox has called it the ChatGPT N objection. And they always say, so what happens? What are you going to say if in half a year there's going to be a ChatGPT 6.2 and that ChatGPT would get it. And my answer is, one, it's going to be great. Of course, the question would be is how much electricity was spent during this time, but let's put this, suppose we have infinite resources of electricity, especially on the West Coast. But the second question that one might want to ask is, do we understand what happened? Do we really understand why it wasn't getting this kind of example previously and why it's getting it now? And for that, you don't need to be a scientist. You can be a Ben Taskar who makes a point of not understanding. Okay, you can really. I mean, Ben would be the first to say, "I have to understand it, because if I don't understand it, I can't build an efficient machine." So, he can be tongue in cheek about beating the other guy, whatever, but he knew extremely well that in the absence of an understanding of what happened here, we would not be able to solve the problem. It's very clear. Otherwise, I wouldn't have put this quote from him at the beginning. Okay. So, I showed you two such examples. And in each case, I looked at a somewhat different aspect of things. One was very, very low frequency kind of phenomenon that is very clear to everyone, but the machine fails on. And the second one is just the simplest run-of-the-mill ambiguity, which the machine fails on, and it's not clear why. And again, there's no learning at all. Here is another aspect of these machines. So Ilya Sutskever is somebody I'm sure that everyone in this room knows. And one thing he said a couple of years ago is to predict the next token well enough means that you understand the underlying reality that led to the creation of that token. And a big deal has been made of next item, next word prediction in the case of language. I know that you use it because I saw your lecture yesterday. But in the case of language, people make a big deal out of this ability to predict the next word. And indeed, if you look, so there are studies like this one by Ariel Goldstein, Uri Hasson, and some others at Princeton, where they try to correlate people's ranking of the next word. They have like a moving window where they show people words, and then they show the next word, and then they show yet the next word. It's like a moving window kind of method. And people are expected to rank words, or sometimes they're expected to generate the most likely word to appear in the next position, something that used to be called the close procedure in 1950s psychology. And they show quite good correlation between the predictions of humans. This is like taken out of like 500 humans here, between the prediction of humans and the prediction of these kinds of machines. And that's pretty good. But then you look at the kinds of texts that they have. And here, this group, the Goldstein-Hasson group, for some reason, they use catchy texts. So this is a text from NPR's This American Life. It's a very famous text about a gorilla that I think it's called the monkey in the middle, this piece. It's actually a very amusing piece about a photographer who wanted to photograph gorillas, and the gorilla grabbed the camera and made a selfie, and then there was an issue in a court in New Zealand who owns the rights for this image because it went viral, of course, and there are all kinds of things. But the important thing is there's nothing in the choice of this particular text other than it's amusing, and that's why it's catchy, and that's why it gets published in Nature Neuroscience. There's nothing in this text that suggests that there's anything about language that was probed other than some funny story. Don't even try to look for VP ellipsis in these kinds of cases. So this is easy stuff. And in fact, one group, which is a group in École Normale Supérieure in Paris and Tel Aviv University, so it's Noor Lan, Emmanuel Shemla, and Roni Katzir, they actually tested it in some more elaborate contexts. It's like a debate in this little corner with 3.5 linguists argue with one another. And what they did was they showed that, in fact, in certain kinds of cases, The surprisal here is a measure of expectation. So the higher the surprisal would be at a given word, the more expected it would be. So here, if you look at this sentence, if I say, I know who you talked with yesterday, then the word yesterday is expected. But if I know who you talked with Mary, the word Mary is not expected. And the results of the predictions of the machine, which is what you see in this little graph, in fact, are correct. The machine successfully identifies that there was a word missing there, and that's why it does not expect for there to be a noun, a name like Mary, but it accepts easily the existence of some kind of an adverb like yesterday. But if you test, however, so this is a good prediction of the machine, but if you test it on somewhat modified version, which is, I know who John's talking to us is going to annoy, and then one continuation is soon, and the other continuation is you. I think I got the colors here backwards, and you can see that the wrong prediction. Oh no, I didn't get it backwards because this is the blue here. You can see that this is an incorrect prediction. So again, it's just a little vignette. This is not what I would base a rejection of an approach on, but it's a little vignette that shows you that when you start getting a little bit more sophisticated, or like when the going gets a little tough, these machines tend to collapse. And it's our job to make make the going tough for these kinds of machines. So here's what we can do, we linguists. Here's what we can contribute. We can help in setting up benchmarks. Instead of like battling, we can like saying like Chomsky, no, this is not something you should do at all. But Chomsky is 96, mind you, and we can just identify the kinds of cases that should be used. We can help the construction of linguistically constrained algorithms. This is the most important thing. We're going to prune your computations by quite a bit. And again, the training sets, I think, have to be modified and not just like feeding these machines with Wikipedia. To me, I'll tell you the truth, when I look at the kinds of training sets that people are feeding, I feel like I'm watching a remake of the movie The Shining. You might remember that there's this that he's writing a book, John, what's his name? John, no?
Jack Nicholson.
Jack Nicholson, thank you. I'm deaf on top of everything. So Jack Nicholson is writing a book, and then in the end, it turns out that he was actually typing the same sentence. I don't know if you remember what it is. Like lots of work and no play makes Jack a dull boy, right? Yeah. Okay. So he's typing the same sentence. I sometimes feel that these guys are feeding the machine with the same sentence all over again. All the time, just, the words keep changing, but who cares? The structure is the same. The properties are the same. And again, you can think about all kinds of ways in which we can help instead of rejecting. Some people have done that just, for the sake of acknowledging the work of others. I think it's important. So there's a couple of groups at NYU, Tal Linzen and Sam Bauman and this guy Worstadt, who have done some things like this, but it's like few and far between, these kinds of tests. Finally, in the last 5 minutes, let me spend a little bit on showing you what's happening in the brain. So, there's a lot of work on vision in humans, in animals, extremely just fantastic works. And here you can see an example of a work from almost 20 years ago, coming out of Tommy Poggio's group at MIT. And in this work on the left, there was a feed-forward network that was identified for object recognition. And the reason I put this one and not others is because these guys took anatomy seriously. I happen to work in an institute of anatomy. I'm collaborating, I think, with the best neuroanatomists in the world. I've been extremely lucky for the past 15, 20 years, and I take anatomy very seriously. And so do these guys. And also, so do people like Kalanit Grill-Spector at Stanford. And when you look at the degree of like how fine-grained their models are neurologically, you know that this is something that should be taken seriously. So these are fantastic applications of large language models, of neural networks more generally, to neurological work. And this is the standard that we should seek. And again, I'm saying it in admiration because in language, there's nothing like it. Well, there's an example from speech, but we can actually skip it. And there are a few examples. I'm very sorry to say that most of them come in the past few years from my lab, in which you actually see very, very fine distinctions, both in syntax and semantics, that pertain not only to small brain areas, but actually to brain areas which are anatomically coherent. There's something called cytoarchitecture. You may have heard about a guy named Brodmann. Some of you may have heard about Brodmann areas in the brain. There's some notion of anatomical coherence as observed at microscopic levels. And what we try to do is to go by the dictum that, you want pieces of cognition and pieces of brain, and both of them have to be motivated and coherent. So the pieces of cognition come from one world, the world of cognition, in this case, of linguistic theory, and the other kind of piece comes from the world of anatomy, as the cortical tissue is parsed by my colleagues, anatomists. And here you can see some such examples where syntax and semantics actually live adjacently but form different regions. You can also see it three-dimensionally here, and you can see some kind of a reconstruction where you can see these are the traditional language areas, what's called Broca's area, that's divided at least to two pieces. And next to it, there's an area that has semantic functions or logical functions. And what you can see here is a very good match between the anatomical characterization of this area and the functional one. And when you think about it, you have syntax and logical functions living side by side. And I think this is, if you want to be poetic, you can think about the place where language stops and thought begins. So some people are concerned with such things, but I really think that this is a place where linguistic meaning ends up with some kind of a logical form, and this is what it looks like. And I don't think it's accidental. It's actually very close to the way of decision-making areas, and these decision-making areas and inference-making areas are done over some kind of logical representations. I just don't know how else to think about it. So, this is the level that I think one should strive for as a beginning, not as an end. And what do we have in the world of modeling large language models that has gotten a lot of attention? Well, basically the method is quite simple. You look at behavior, as you could see a part of it before in this Goldstein-Hasson work. The idea is you have behavioral scores, you have large language model scores on some kind of text in a next word prediction task, and then you have brain scores as monitored either by electrodes during neurosurgery or by functional imaging methods of this or that type. And the reason I'm showing this to you is just to show you the magnitude of the claim, which is the human brain processes incoming speech similar to an autoregressive deep learning model. Okay, it's unbelievable. And look at the fantastic anatomical resolution here. It's like a joke. Okay, and similarly, a group at MIT headed by Ed Fedorenko does similar work using fairly similar materials. You can also see the anatomical resolution, and you can see that GPT-2 explains almost all the variance in both fMRI and ECOG data. That's like, direct recording from brain tissue, from sentence processing tasks. And the message to remember here is that the sentences which are used are just like stories, again, monkey in the middle, which is used at the top one, and things of that type. So, you don't make the right linguistic choices, this is what you get. Okay, I think it's time to conclude. And again, just to remind you, on the issue of constraints, I showed you at least that you need some system that constrains at least the possible interpretations of sentences of particular types. I showed you that, there's some experimental data. Once the materials are chosen carefully, again, in a theory-driven manner, you get better resolution. And again, the biology is not taken sufficiently seriously. I think that in many instances, it's just used for some kind of a rhetorical purpose. So again, the only way I can propose anything constructive is, once again, as I said, to take the pieces, either the anatomical pieces beautifully that come, this one comes from a paper by my colleague Katrin Amundsen and other people in UNISH in the Forschung Center, that gave an almost complete cortical parsing into what's called cytoarchitectonic areas, which are microscopically defined brain areas. These are the main language areas, what's used to be called Broca's area, still does, I guess, and using the functional pieces as taken from linguistic theory. Again, you have to be, you have to negotiate these kinds of things. It's not easy, but these are the right kinds of pieces that one might want. So we have brain pieces, we have language pieces, and hopefully we're going to end up finding small neural networks that would fit this. And I just want to tell you that the first time I ever saw, I was not introduced to him, but I ever saw Jeff Hinton was, I think, around 1985. I was at MIT, and there was this thing called Center for Cognitive Science, and a young postdoc, I think maybe not, maybe he had a job already at CMU or something like this, was a guy named Jeff Hinton. And he came for a Tuesday evening lecture at the Center for Cognitive Science, and he gave a talk about Boltzmann machines, for which he ended up getting the Nobel Prize. In the audience, sitting just next to me, were two philosophers. One was a guy named Jerry Fodor, who some of you may have heard of, and the other one was his friend Daniel Dennett, two very famous philosophers. And they were sitting there and giggling all the time, whispering and giggling, and Hinton was getting increasingly nervous. And at the end, this was about that a couple of years after Jerry Fodor had published his book, The Modularity of Mind, which gained fantastic success in the 1980s. So at the end of Hinton's talk, he got up, Fodor, and he was a big guy, and he said, "So what about modularity?" Like that, like a mafia don a little bit. And Hinton said, "Look, I have nothing against modularity. I think there may be small modules, each of which is a network." I never forgot this. I don't know if he still believes in this kind of solution. I hope he does, but I haven't seen any evidence. Okay, but I never forgot this because I think this is just the right kind of answer. And sadly, what Fodor did, he just looked at him and he said, "Good." That's all he said and sat down. Okay, well, it's not so happy, you see these kinds of things, you're not happy. Anyway, so this is what we end, and going from Plato to a neuro AI, I think one must conclude that we need these kinds of concepts like linguistic theory, and we always have to keep in mind what many of you I'm sure do, that whatever you do is a simulation, and the fact that the machine manages to simulate the human and it becomes indistinguishable from human doesn't mean that this is the right theory. And this is something that Turing himself, in his famous paper, Computing Machinery and Intelligence, this famous 1950 paper, this is a quote, a direct quote from that. And again, I can only advocate, approaches to linguistics that really use what I just suggested. And I think before we end, I want to end with a little quote from, this comes from my book, but I want to end with a little quote from Ben, because had he been here, I'm sure he would say what he used to tell me, enough already. Maybe it's time for you to be put out to pasture. Why don't you write a textbook? Or maybe I should. Okay. And here's the family in nicer days. Thank you.
Thank you. We have time for just a few questions. Yes, please, Arnold.
this off to help hearing. I'm Emily, as I
Yeah,
spotted.
I know.
Thank you for this. I really appreciate the neurological, biological approach. I just want to let you know that it's not true that you can't implement a symbolic approach. We've actually been doing it in head group and phrase structure grammar, which if you ask Hinton is Chomskyan, if you ask Chomsky, it's not.
Nothing to do with this doctrinaire kind
Yeah,
of stuff, or what things that work.
So yeah, and so it works. We have the English resource grammar, been developed since 1993. You give it any well-edited English
This is what
sentence.
Karl Pollack started.
Yeah, and then look at your something about it. So there's a large open source
Yes.
implemented grammar of English with rules that you can run on a computer. So those do exist.
So how do these guys talk to you?
No, they say no one does that anymore and ignore the fact that we have still been.
No one does that anymore.
Right, autonomous driving.
No one does that anymore. I've heard that, yeah.
We're still here. Thank you.
Thanks. Should be incorporated, no doubt.
I'll send you the link.
Do you want to repeat that for the folks on Zoom?
Oh, so what Emily said is that I incorrectly said that there are no implementations of symbolic systems, and in fact, there is an approach that's been like kind of considered to be wrongly the West Coast version, but it's not. It's called generalized phrase structure grammar or head grammars. That's been developed actually at Stanford since the mid 1980s, I think, something like that. And that it's been developed to a working set of programs. And people in the world of neural networks say, well, nobody does that. Did I quote you
Yeah.
faithfully? Okay, thank you.
All right, question.
I'm approaching you just because I'm deaf.
You don't want to get the microphone. So I don't know, thank you so much for a wonderful talk. I don't know too much about some of the areas that you're discussing, but I will maybe read a little bit about modularity. The idea that there may need to be kind of some heterogeneity in these big models in order to either emulate actual human thought or do better at certain tasks makes a lot of sense. But you see, you had a slide that you recommended being organized by language theory. Why does that necessarily need to be the case? So the heterogeneity and having some modules makes sense. So why do they necessarily need to have language theory kind of organizing that? Or did I misunderstand, which is very possible?
You understood, but there's a piece missing. So the thing is, I'll tell you, in Yiddish, there's a saying that goes, Alle Yevonim haben ein Onim, which means all the Greeks look alike. Okay, it's kind of a racist saying, but the point is that I'm sure that as a Greek, you would disagree strongly. Now, from your perspective, language is just like this one entity. But when you start looking more carefully, it consists of many, many sub-modules that are critical. And the reason you know these are sub-modules is not because you have an intuition that they constitute different cognitive domains, but because you see evidence, empirical evidence that they work separately and that they interact. This is exactly what makes you convinced that you want to assume a separate module. You give some independent reasoning to its existence, distinct from something else, and then you show how it interacts. This is the demonstration from pronouns is exactly that. It's an interaction between a theory of how pronouns fix their reference, what kinds of scenarios make one interpretation true and another false. This is what I showed you. And on the other hand, here you could see how pronouns fix their reference in particular ways on missing pieces of text, which is those ellipsis things. So, Bill did too. And you can see that the way the missing pronoun fixes its reference is restricted. And this is for you evidence that in fact, they're like one piece of theory that talks about pronouns fixing the reference somewhere, and another piece of theory that talks about how you reconstruct missing material. And from their interaction, the need for certain kinds of constraints emerges. There's an internal logic that leads you to think that within syntax and within semantics, they're actually modules. And, my crazy career that has not been particularly successful has been to try and fish out these modules from the brain. I think empirically, I think there's been some success. Sociologically, complete fail.
The rest of them, I don't know why we need to have.
Yes.
If we can get this right, that language itself is to reflect on how we process the world in front of us. And then the innovation of ChatGPT could be just like a mirror in front of us with the whole business now it's broken and we are still seeing it. And then when we are interacting with it, the meaning of it is producing and processed again. So I that's what I think when when this is happening, and then when you're giving all these examples of how our original understanding of the sentence itself, like the examples that you gave out, and because now we would debate if the this AI thing would be real art, with ChatGPT be somebody that we could rely on, something that we could rely on, but eventually when we interact, when we process things,
It'd be different.
yes.
Let me differ with you a little bit, and I don't think that one of the points that I made in this talk was to try to convince you that ChatGPT is not a mirror of anything. It's not a mirror of us. It's not a mirror, not just because it is, sorry, I'm just going to move back here, I think. Yeah, sorry. And so it's not a mirror, not just because its inner structure does not resemble our inner structure, but also empirically, it doesn't mimic our behavior. When you look at the right kinds of case, it doesn't mimic our behavior as has been claimed or as it should. Yes. Sorry, but it's my.
That's all right. Thank you so much for Shiraksha. Thank you so much for this wonderful talk. I was actually just teaching an LLM class this morning, and I talked about Chomsky and then Turing and all those things. I actually took pictures of your slide because I'm going to now show those students on Wednesday. Remember I told you about language model goes all the way back to decades ago and so on. Anyway, well, my question, actually following up on your previous comment, I agree with you that these systems are not mimicking us. They're not supposed to be mirrors of us. But actually, that's sort of my point, that why are we expecting them to behave in a similar fashion? So why are we testing them using the kind of benchmark that we will use to test somebody, a humans, grammatical, understanding, and not just humans, but native speakers, because I'm not a native speaker for English. And, now my English is better than what it used to be before, but I certainly see this in my past behavior and my students, who are not. And so they could misinterpret those, that doesn't mean they're not smart. They just have a different characteristic, they have different behavior. I don't expect them to understand Shakespeare the way, native speakers would.
Thanks a lot. Let me make sure about what I did not say. Not for a minute did I suggest that these machines are not smart. I didn't suggest they're smart either. Okay, I just, this is not the kind of question that I have an opinion on. I think it's important not to have an opinion about this kind of thing. But the question is, what exactly do you want of this machine? If you want it to work, maybe you're an engineer, you want it to build the best machine there is. And I think Drago in his talk mentioned how he and Ben used to fantasize about building the best machine ever. And I'm sure that you still fantasize about it.
In some domain specific. There's always no.
It could be in any domain. It's a fantastic fantasy. This is why I call this the AI fantasy. It's a fantastic fantasy, and I think you should keep fantasizing in every domain. Okay. But this is an engineering feat, and I think ChatGPT is an amazing feat. I mean, I wish I could come close to this kind of accomplishment. No way. But it's a different kind of thing than what scientists are after. And it's important to keep this distinction. Scientists want to find this, uncover the structure of the world, understand it. It's not about building machines. It could be, it doesn't negate it. I wish it worked together, but it doesn't always work together. But there's a second thing which I hinted at one point, and I said, if you don't use the right benchmarks, you pay the price of then the machine failing. And it may fail in places that you cannot even imagine. So even if these cases of VP ellipsis are cases that are very rare, and I'm not a native speaker of English either, okay? And in fact, VP ellipsis doesn't exist in Hebrew in the same way. And sometimes I can see myself that my judgments on English, and I've been speaking English for a while, and I've been studying the structure of English for quite a while, and still there are cases in which my judgments collapse. In fact, I can tell you even that certain kinds of things that come close to ellipsis were the only places where Chomsky had the wrong judgments in Hebrew. He spoke Hebrew at home in Philadelphia because his father was a professor of Hebrew. And these kinds of cases, these very rare cases, were the only instances in which he would argue with me. And I remember telling him, listen, it's the one thing I know better than you, just leave me alone, because these are really lacunae, very unusual ones, but these are the ones to look at. One, because they can help you understand the inner workings of your machine, because these set exactly boundary conditions. This is what you want, and saying that you should ignore them, it's like saying, well, particles are very small, why bother? It's exactly the same, It's like, physicists, they go and they shoot this particle 10 miles and it's some kind of an accelerator that's extremely long, extremely expensive, then they make a generalization about the universe. They're not crazy, they know what they're doing. But somehow this logic collapses when it comes to language. All of a sudden, there's this thing called out of distribution that gains a lot of traction. These are the cases you should look at. I wish I knew how to find the right cases that are out of distribution, because this is where you need to focus on. So I beg to differ.
Actually, because I speak 3 languages and I'm from anthropology, so I'm more focused on how to acquire the second language or something. I did a research. Also, it's like a test for GPT. I use different language, Chinese, Korean, and English to ask the same question, but it all reflect different answers. GPT did give me an answer, an explanation for that. They say probably the listener, as a Chinese or Korean language user, they prefer to understand a specific topic from a specific angle, rather than having the whole picture of the thing. And that's an explanation, and I accept that. But when it comes to, because I did another research, it's about some institutions just develop their own machine learning or softwares to interpret and they use the database there, they build themselves, and they try to give make it more useful complaints compared to GPT, which is an open resource thing. And do you think he had Professor Shaw is an engineer and you are linguistics, so how do no matter how do you defend yourself? How do you think about I mean, yes. So.
I have a very simplistic response to that. So I lived for about 14 years of my adult life. I lived in Montreal. Montreal is a bilingual city, decreasingly so actually, because the Anglo community is getting pushed away. And language is a big political deal there. So there's a lot of money for bilingual research, and I was highly encouraged to study the bilingual brain. And the problem is, for me, from the very beginning, I refused to do it. That's the punchline here, because the problem is, I have so many problems in one language. And adding a second language introduces a huge bag of words. I can give you examples for some. How do we define the proper exposure that would count you as a truly bilingual or half bilingual or 1/3 bilingual? Do you go by accent? I was listening to Drago's talk yesterday. His English is impeccable, at least as far as I can judge, but his accent is Bulgarian, right? His accent is Bulgarian. Does it make him bilingual? Does it make him trilingual? I don't know, because he speaks English with a Bulgarian accent. It's very, very difficult to define criteria that would make for the study of bilingualism. I can tell you, I gave up on a lot of dollars, Canadian dollars, mind you, but still a lot of dollars, okay, when I was there, because I didn't want to do it. It's like too many variables, too many balls in the air. So I'm sorry, but I'm ducking your question by trying to be fun. Okay.
I think we need to finish it up. Thank you. I did have actually my own question. So if we are looking at domain and modularly defined language models, how do we trade off the potential for a fine-tuning bias versus the potential ability to generalize more broadly? Because some of the use cases, and now I'm just focusing on the application itself, right? So we are using these models, and everyone in this room, I contend, is using these models.
Me too, This is fantastic. Would you think I'm stupid? No, of course I use it, but it doesn't mean that it doesn't lead to the same kind of hype, that's all. But
Sure.
But sorry.
So how do you potentially either constrain, put warning labels that allow people to better understand where the failings are? We see the examples you've shown, but those are more, syntactic and semantic, meaning related examples. We see, in my case, I look at biases that have to do with non-ableism. And at the outliers of the distribution, we also see the biases that these models are showing. The question is how to functionalize people and their understanding of how they use these models. And when you do fine tune it for a particular instance, case, module, what have you, how do you interface? What's the digital dialogue that you want these machines to have with the users in order to guide their adequate use of the model?
Of course, I have no answer, but let me tell you, no, I really don't. But I can tell you that I can tell you what this problem that you raised on, like, let's say generality versus variation, how it interferes with my own work, or how it interacts with my own work. So the way it interacts with my work is this: I test the brain. And I have to make choices all the time. What kinds of tests do I use? Now at the operating room, we try to I try to help the neurosurgeons to know which areas they should stay away from while removing pieces of brain. It's actually quite dramatic, and it's frustrating but rewarding at the same time. But the basic idea is everybody knows that when you remove a larger piece of a tumor, you reduce the likelihood of recurrence. You increase the chances for remission. Now, the thing is, like every other organ, if you remove more of the person. And what you do is you use an electrode. It's a very old technique, but it's been revived for a variety of reasons. You use an electrode, you block an area, and as you block it, you test the patient. So now the question is, what kind of test do you give the patient? It's exactly the same kind of thing. You want to know where to flag. I want to know which kind of construction do I use. And you have to make choices here. Again, there you are limited. You know, you can usually test a patient with this kind of technique between 30 and 40 minutes, depending on all kinds of individual variables. And the most important variable is the quality of the anesthesiologist. This is really the most important one because you wake up the patient in the middle of surgery and you use them as your navigation device. This is what you do. And you have to make very clear choices as to what kinds of sentence types you test them on. And what you try to do is you try to use what we might want to call, and it's like a neologism in a sense, the core kinds of distinctions which carry over to other languages, which has a lot of processing costs and things of that type, and for which we have evidence from the healthy brain. There's no like a priori logical reasoning, which is what you're looking for, that would set up criteria for how exactly one does that. It's all has to be empirically based. You know, I'm a concrete guy. I move on empirical evidence. As I said, that this is what we do. There's just no other choice. But otherwise, you miss something important. So sometimes, if you're lucky, you save somebody's relative clauses just because you showed that it's true, it's really true. And because you show that this particular area should not be touched, you know, and sometimes you don't, sometimes you fail, but at least you tried. And it's the same thing with all kinds of empirical evidence. When you approach a healthy person and you test them on functional MRI, what leads you to make choices? Now, many of these guys, as I showed you, have given up on it, and they just give them texts. And if the texts are amusing enough, or they involve a story that's familiar, they get published in a big journal because then it gets to the BBC website. It's really true. This is how it works, and you guys know. But this is really the wrong approach. The right approach is just to make decisions and simply be aware of the decisions. Now, I know that I'm not giving you an answer, but this is the best I can do and tell you that, you know, we're in the same boat. We have exactly the same problem. I'm now trying to, the test that we're having for the OR is currently, this particular text is currently in German, and we're now translating it into Hindi. And this is a very simple test, and already we run into problems of, you know, how exactly does this test carry over to Hindi? So, you know, I think the best Hindi linguist in the world, Rajesh Bhatt, who's at UMass Amherst. He's advising me on this. I have my team in Mumbai, and you know, we're trying to do this. But there are all kinds of issues that need to be honed, and it's very, very difficult, and you're wrong much of the time.
Anything with that? Oh, sure.
So one of your main points is that let's build in all this constraint structure into our language models. But you didn't mention exactly what it needs to do. Like what's good constraints and bad constraints? How do you balance? What do you aim to achieve when you introduce them? Right? Everything's relative to a goal. Right? Too much constraints, you won't come up with beautiful poetry. For example, a mixed trip case or song, right? Like what constraints need to be built and which ones shouldn't?
It's, you know, from a different angle, it's a very similar question to Anat's. How do you make choices? How do you make choices? I completely agree with you. But the first thing that I would suggest is let's try and negotiate something. You have to negotiate it, and it's basically negotiate it with the way you defined your goal. I completely agree with you. And with your findings. You have to try. If you don't try, you don't know. You know, we can tell you what are the central constraints in syntax, or what are the most important things to mind when you look at semantic systems. Maybe these are the wrong things for your needs, but you have to try.
Well, what should be the goal? What should be the goal?
What should be the goal?
But again, you know, the goal. Well, his goal is to build the best machine ever. This is no. It's his goal, and he's right. This is just the right goal. This is just the right goal. I mean,
It's the goal to do best on the tasks you really want to solve, which then you have great metrics and then you optimize, right? So it's not It's not an abstract great machine. As an engineer, which I kind of think I'm like Ben, maybe I should say this, like Ben, I think I'm an engineer. Whenever we were solving something, it was somewhat consistent. You pick a task, you define benchmark that correlated to success in the task, and then you maximize it, right? There is no special claims that 10 other tasks work the same way. Then, if you're solving other tasks, you will, define the right measure of success, and then you'll have the best task solver ever. That was mostly the mental process. So it's not exactly universally the best thing ever in all ways. That's a bit ambitious. But, maybe which tasks are like, how do you think about it?
So here's an easy one. The task is the task that Ilya Sutskever recommends, because he says if you're able to predict the next word, it means that you understand something profound about the mental process, the underlying mental processes. Let's use this task. This is exactly what these guys from Paris and Tel Aviv did. Okay, and all they did was a little demo. But then, of course, the next step is to take the kinds of constraints that lead you to the interpretations that are licit there, and see if you can impose them on your system and get good results. But this is not something that anyone does, at least to my knowledge. I wish. We can agree. I mean, again, this is like a general talk. So we talk in generalities. I completely agree with you. You got to be focused. And you got to be focused on a task and so on and so forth. But here's one example, next word prediction. This is what everybody uses these days. I don't know why, but this is what people use. Maybe because Ilya Sutskever said that's possible. So, but it's not a bad thing to explore.
All right. This was a wonderful conversation. Thank you all for being here. Please enjoy our reception if you're here.
And I just
to thank our speaker.
Yes. Before you thank me, I just want to say there was one right choice I made in life. I chose the right news.
And we'll continue the conversation offline. I don't know how to turn this thing.
Thanks so much.
Thank you. Sorry about that.
Yeah.